Lesson 11, we're looking at section 6.1, the verification of trigonometric identities. Now, in terms of these identities, okay, you're looking at the reciprocal identities, the ratio, the Pythagorean, and the odd and even identities. Now, the reciprocal identities are these ones right here on the front page, okay? The fact that cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. Your ratio identities are the same thing as these quotient ones right here, okay? That's cotangent over cosine, or sorry, cotangent is sine over cosine, cosine over sine, and tangent is sine over cosine, okay? The next one is the Pythagorean identities. Now, these ones we've worked with before. This first one is the most basic version. It comes from the unit circle, the fact that I have the x squared plus y squared, I'm sorry, the other way around, y squared plus x squared is equal to 1 in terms of a circle where the radius is 1. And the fact that on the unit circle, my y is technically sine squared, sine, and x is technically my cosine. Now, from this identity, dividing all the pieces by cosine gives us this one here. Dividing all the pieces of this one by sine gives us this one here. Okay, so those ones we're going to want to know. Last one, in terms of odd and even, specifically the fact that for cosine, and I believe it's only cosine, it's you can reflect it over the y-axis. Okay, again, the cosine function can be reflected over the x-axis. If that's the case, that makes it an even function. Again, even functions have y-axis symmetry. Odd functions have origin symmetry. Now, which of those functions have origin symmetry? Well, specifically sine, tangent, and then their reciprocals as well. Okay, so we've got that detailed down now. The guidelines for verifying trig identities, those are all written right here. In terms of these steps, now sometimes it might be better to use one step before the other. Sometimes it might be better to use them in the order that you see them. Generally, it's a good idea to start with the most complex side first and simplify it until it gets to the other side. That's not always the case. Sometimes we'll simplify the most complex to a point and then work on the other side. Perform certain operations, adding, subtracting things to both sides, dividing, squaring. It could include factoring, multiplying by the conjugate. There's a number of different things, okay? Make sure of previously verified identities. Now, what I mean by that is that we can use previous things we've already proved, okay? We can use things we've already proved. Rewrite equations so one side is in just sines or cosines. Write equations so that one side is a single trig function. Common denominators. Always remember what your end result should be. Okay. Now, later on in the future, we will talk about making sure that all of your angle measures in the trig functions are the same. But until we get there, we're really just playing with these concepts. Okay. So, let's talk about this first one. And again, the question is verify. Read that little extra piece. Is there a way to answer this question without showing work? And that answer to that question is absolutely no. Okay, absolutely no. If you try and do these problems, you need to show me work. I need to see what steps you took to get to the proof, the value or equal signs such that it is obviously true. Okay, so now let's actually just start with this one right here. So I have sine x, cotangent x, secant of x is equal to 1. Clearly, this side is most simplified, so I'm going to simplify the more complex side, this side over here. Now, what things should I do? Well, first of all, maybe I don't really care for the fact that this is cotangent and this is secant. I'm more comfortable working with sines and cosines. So I'm going to leave this as sine of x. But that cotangent, I'm going to change it to cosine of x divided by sine of x. Okay? I'm also going to change that secant to 1 over cosine of x. And I hope at this point you actually see what I have. This sine will cancel out with this sine because they're the same angles on the inside. This cosine will cancel out with this cosine because they're the exact same angles. And all I have left is this thing is equal to 1. This right here is the work. The fact that this equals to the 1 verifies the identity. Okay, so this is a true statement. And that completes that particular problem. Let's take a look at the next one. Okay. Now, this one used changing all to sines and cosines. This next one actually gives us a bunch of squared things, and that might be important. The fact that we have squared things with a plus or minus 1, there's a number of different ways to prove this particular identity. What I'm going to do is I'm going to start by getting one side similar to another. The way I'm going to do that is I'm going to add the 1 to both sides. Okay, I'm going to move all the terms to one side. Now, when I do that, that's going to give me 2 minus 2 sine squared x is equal to 2 cosine squared x. Okay, the next thing I'm going to notice is the fact that, well, wait a second, if I can do that, can I divide everything in here by 2? I'm going to divide both sides by 2. Doing so will cancel out these 2's, and on this side it'll cancel out the 2 here and the 2 here, because I'll distribute the division to both of these pieces. That will give me 1 minus sine squared x is equal to cosine squared x. Now, some of you might be able to say, hey, we're done. If you can't see it, maybe by adding sine squared x to both sides, you'll notice that I have 1 is equal to cosine squared x plus sine squared x, and I am completing the fact that that thing is this identity right here. Okay? So by getting to something that is obviously true, okay, I notice on this one, I changed the way that I use these. I manipulated both sides of the equation until I got to something that I know for a fact is true. That verifies this identity. Okay, so this is true because if I started here and I worked my way up to that thing, okay, if this is true and all these statements are accurate, then that must also be true. Okay, so this verifies this particular identity. Let's go ahead and look at the next one. Cosecant squared minus cosine squared, cosecant squared is equal to 1. Okay. Now, for this one, the first thing that I'm going to recognize is the fact that there's a cosecant squared in this term and in this term. If it's in both those terms, why don't I just factor it out? Okay, we still have those rules, those properties that we can apply. So, I'm going to factor out the cosecant squared out of both terms. When I factor out of this term, there's nothing there, so it's just left with a 1, minus cosine squared all by itself, because cosecant squared is factored out. This is all supposed to be equal to 1. Okay. What's cosecant squared? Well, that's just 1 over sine squared x. 1 minus cosine squared. Looking at my identities here, 1 minus cosine squared is really just this sine squared. Okay. Now that's by manipulating this particular thing, subtracting cosine from both sides. Okay. So that gives me that I have this thing, which is really just sine squared x. Well, these two things cancel out. I get this thing is equal to 1. That matches up there. That's checked. Okay, that verifies that identity. Again, these might be the most efficient way. They might be the most inefficient way. I don't know. But what I do know is that this method worked. It got to say that this thing here is the same kind of equation as 1 equals 1. If I have 1 equals 1, that's always true. Okay. Let's go ahead and look at this next one. Now, there's a couple different methods to work through this particular problem. I'm not sure what's the most efficient. Okay. What I'm going to do is I'm going to say I don't like either one of these sides. I don't like the fact that they're both fractions. What I'm going to do is I'm going to multiply both sides by sine x and 1 plus cosine x. And the reason why I'm going to do that on both sides of this thing, okay, is so that I can eliminate both denominators. And this is cosine x. Okay, so this is sine x. So, on this side, the sine x is going to cancel out with the sine x, and I'll be left with 1 minus cosine x and 1 plus cosine x. Okay, and on the other side, the 1 plus cosine x is going to cancel out with 1 plus cosine x, and I'll be left with sine x times sine x, which is really just sine squared. And this actually worked out very nicely for us because this side here, you'll notice that these two things are conjugates of each other. And when I multiply two conjugates together, all I'm left with is the square of the two terms, square the first, square the cosine, okay? And then the middle terms actually cancel each other out. If you don't trust me, go ahead and FOIL it out, okay? This is what I'm left with, and I get sine squared x is equal to this thing. Well, if I add the cosine squared to both sides, I get sine squared x plus cosine squared x is equal to 1. Okay, and that checks. Now, you could stop here. I would accept you to stop here. In terms of overall, if you stop here and this is wrong and you say that this is verified, I'm not going to give you very much credit. Okay, you need to make sure that this step right here is absolutely concluding the problem, and I don't want to see more than one step missed. So if you go to here and tell me that this is verified, I'm not going to accept that. You need to show me that this is equal to this or that this is equal to this before I can accept that it's verified. Last problem. So before I actually go to this last problem right here, let's review things. Changing the most complicated side to sine over cosines, or sine and cosines. Manipulating both sides, okay, until the squared terms will get me the Pythagorean identity. Factoring. We have a method that we can factor things out if it helps. Eliminating the denominators. Okay, that's a nice, consistent thing we can always try and do. So in this one right here, okay, the question is what should I try starting with? Well, just like I said up here, I don't like fractions. So what I'm going to do, it might not be the best move, but what I'm going to do is I'm going to multiply both sides by 1 plus cosine x, just to eliminate that denominator. Okay, that's going to cancel out with that. I'm going to be left with sine x plus tangent x is equal to this tangent times the 1 plus cosine x. I'm going to distribute that through. So I'm going to have tangent of x plus tangent of x times cosine of x. The next thing I'm going to do is, well, I have a tangent of x, and that matches up with this tangent of x. So I'm not going to modify those two at all. There's a sine. I need this piece to be sine. If it's not, then I did something wrong. Let's go ahead and check it. Tangent is sine x over cosine of x. That's times cosine of x. Cosines cancel out. This piece right here is really just sine. So now I have sine x plus tangent of x is equal to tangent of x plus sine of x, and that problem is verified. That concludes notes 11. I suggest with these problems that you take your time. You need to show the work. Test, quiz, homework, everything. Okay, it'll be very difficult for you to go through these problems without showing the work. Also, from this point forward, I strongly suggest that you keep some form of an identity sheet in front of you. Okay, now this 11, section 11, doesn't help you having this particular identity sheet, but in terms of having the identities understood, these ones are the most important ones that we're going to want to keep in mind. These ones are the most fundamental. Okay, you'll keep these ones in mind, not because they're difficult to keep in mind, but because we've been doing them for so long, you shouldn't forget them. That concludes